The Maxis Pull-It 3000 is a heavy-duty cable puller designed for commercial and industrial applications. It's commonly used by electricians, telecommunications technicians, and other professionals who need to pull cables through conduits, walls, and other obstacles. This cable puller has several features. Firstly, it offers a 3,000 pounds pulling force. Secondly, it provides infinitely variable speed control, allowing for precise adjustments during cable pulling operations. Thirdly, the unit is designed to be lightweight and portable, enhancing maneuverability on job sites. Fourthly, it features an ergonomic design aimed at providing comfortable use for the operator, reducing fatigue during prolonged use. The cost of the Maxis Pull-It 3000 can vary, depending on the supplier, and any additional accessories included. However, one can expect to pay around $1,500 to $2,500 for the base unit. Additional accessories, such as different pull rope options and anchor points, can add $100 to $500 to the cost. Reviews of the Maxis Pull-It 3000 have been generally positive. Some of the pros associated with it are: firstly, it is powerful and efficient in its cable pulling capabilities. Secondly, it's designed to be easy to use and control, simplifying the pulling process. Thirdly, users have found it to be durable and reliable, ensuring a long lifespan. However, there are also some cons to consider. Firstly, the Maxis Pull-It 3000 can be expensive, representing a significant investment. Secondly, some users may find it to be too heavy, potentially limiting its portability in certain situations. The Maxis Pull-It 3000 is a high-quality cable puller that's well suited for demanding applications. It offers a high pulling force, variable speed control, and durable construction. However, it is important to carefully consider both the cost and weight of the unit before making a purchase. If you are seeking a more affordable option, there are other cable pullers available with lower pulling capacities that may be sufficient for your specific needs. In some cases, it may also be advantageous to rent a cable puller, particularly if it's only required for a short-term project, rather than purchasing the Maxis Pull-It 3000. When selecting a cable puller, consider the following factors to ensure you choose the best tool for the job. Firstly, evaluate the pulling force requirements of your typical cable installations. Different cable types, sizes, and conduit runs require varying levels of pulling force. Select a puller with a pulling force capacity that exceeds your maximum anticipated load to provide a safety margin and prevent overstressing the equipment. Secondly, assess the cable types and sizes that you will be working with. Ensure that the cable puller is compatible with the types and sizes of cables you intend to install. Some pullers may have limitations on the cable diameter or weight they can accommodate. Refer to the manufacturer's specifications for guidance on cable compatibility. Thirdly, analyze the conduit types and sizes used in your installations. The cable puller should be suitable for use with the conduit types and sizes commonly encountered in your projects. Consider factors such as conduit material, diameter, and bend radius when selecting a puller. Some pullers may require specialized attachments or accessories for use with certain conduit types. Fourthly, evaluate the available space and access at the job site. Consider the physical dimensions and maneuverability of the cable puller in relation to the available space at the job site. Ensure that the puller can be easily positioned and operated in the confined areas often encountered during cable installations. Portable and compact pullers may be preferable for jobs with limited space. Fifthly, consider the power source requirements of the cable puller. Some pullers are powered by electricity, while others are manually operated. Evaluate the availability of power outlets at the job site and choose a puller that matches the available power source. Manually operated pullers may be suitable for jobs where electricity is not readily accessible. Sixthly, review the safety features incorporated into the cable puller design. Safety is paramount when working with cable pulling equipment. Look for pullers with safety features such as overload protection, emergency stop mechanisms, and cable guides to prevent accidents and injuries. Ensure that the puller complies with relevant safety standards and regulations. Seventhly, assess the ease of use and maintenance requirements of the cable puller. Choose a puller that is easy to set up, operate, and maintain. Look for features such as intuitive controls, clear instructions, and readily available replacement parts. Proper maintenance is essential for ensuring the longevity and reliability of the cable puller. Eighthly, read reviews and seek recommendations from other users. Before making a purchase, research the cable puller model you are considering and read reviews from other users. Pay attention to comments regarding the puller's performance, reliability, and ease of use. Seek recommendations from colleagues or industry professionals who have experience with cable pulling equipment. Ninthly, compare prices and warranties from different suppliers. Cable pullers can vary significantly in price, so it's important to compare prices from different suppliers before making a decision. Also, check the warranty offered by the manufacturer to ensure that you are protected against defects or malfunctions. Tenthly, consider the potential for renting a cable puller instead of purchasing one. If you only need a cable puller for occasional use, renting may be a more cost-effective option. Renting allows you to access high-quality equipment without the upfront investment and maintenance costs associated with ownership. Additionally, renting provides the flexibility to choose different puller models for different jobs. To elaborate further on the features of a cable puller, it is helpful to understand the core components and their functions. Firstly, the frame and base provide a stable platform for the cable puller, ensuring that it remains secure and balanced during operation. The frame is typically constructed from durable materials such as steel or aluminum to withstand the stresses and strains of cable pulling. Secondly, the pulling mechanism is responsible for generating the force needed to pull the cable through the conduit or other raceway. Common pulling mechanisms include capstan winches, hydraulic cylinders, and electric motors. The choice of pulling mechanism depends on factors such as the required pulling force, cable type, and job site conditions. Thirdly, the cable grip or pulling eye attaches to the end of the cable and provides a secure connection to the pulling mechanism. Cable grips come in various sizes and designs to accommodate different cable diameters and configurations. Some cable grips are designed to be reusable, while others are intended for single-use applications. Fourthly, the control panel allows the operator to control the speed and direction of the cable pull. Control panels typically include features such as start/stop buttons, speed control knobs, and emergency stop switches. Some advanced cable pullers may also incorporate digital displays to show real-time pulling force and cable length. Fifthly, the rope or cable used to transmit the pulling force from the pulling mechanism to the cable grip. Ropes and cables are typically made from high-strength materials such as nylon or steel. The choice of rope or cable depends on factors such as the required pulling force, cable weight, and environmental conditions. Sixthly, the conduit adapters are used to connect the cable puller to the conduit or raceway through which the cable is being pulled. Conduit adapters come in various sizes and designs to accommodate different conduit types and sizes. Some conduit adapters may also include features such as rollers or bushings to reduce friction and prevent cable damage. Seventhly, the anchor points are used to secure the cable puller to a fixed object or structure. Anchor points are typically located on the frame of the cable puller and may include features such as hooks, eyes, or threaded studs. The anchor points must be strong enough to withstand the pulling force generated by the cable puller. Eighthly, the safety devices are designed to protect the operator and equipment from accidents and injuries. Safety devices may include features such as overload protection, emergency stop mechanisms, and cable guides. It is important to inspect and test safety devices regularly to ensure that they are functioning properly. Ninthly, the power cord or battery provides the electrical power needed to operate the cable puller. Power cords are typically used for electrically powered cable pullers, while batteries are used for portable or cordless models. The choice of power source depends on factors such as the availability of electrical outlets and the portability requirements of the job site. Tenthly, the carrying case or storage container is used to transport and store the cable puller and its accessories. Carrying cases are typically made from durable materials such as plastic or metal and may include features such as handles, wheels, and compartments for organizing accessories. In addition to the core components, cable pullers may also include a variety of optional accessories to enhance their functionality and versatility. Firstly, the pulling socks are used to grip and protect the cable during the pulling process. Pulling socks are typically made from woven wire mesh and are designed to distribute the pulling force evenly across a cable surface. Secondly, the swivel connectors are used to prevent cable twisting during the pulling process. Swivel connectors allow the cable to rotate freely, reducing the risk of kinking or damage. Thirdly, the lubricant is used to reduce friction between the cable and the conduit. Lubricant helps to ease the pulling process and prevent damage to the cable insulation. Fourthly, the measuring devices are used to measure the length of cable that has been pulled. Measuring devices may include features such as digital displays, preset counters, and automatic shut-off mechanisms. Fifthly, the communication systems are used to communicate between the operator and other workers during the pulling process. Communication systems may include features such as headsets, walkie-talkies, or visual signals. Sixthly, the remote controls are used to operate the cable puller from a distance. Remote controls allow the operator to position themselves in a safe and convenient location during the pulling process. Seventhly, the data logging systems are used to record data about the cable pulling process. Data logging systems may include features such as sensors, data loggers, and software for analyzing the data. When selecting a cable puller, it is important to consider the specific requirements of the job at hand and choose a model that is well suited for the task. Consider factors such as the pulling force, cable type, conduit size, and job site conditions. It is also important to choose a cable puller from a reputable manufacturer with a proven track record of quality and reliability. Proper training and safety precautions are essential when operating cable pulling equipment. Always follow the manufacturer's instructions and wear appropriate personal protective equipment. Inspect the cable puller and accessories regularly to ensure that they are in good working condition.